Hey Annabelle, let's learn about the super resolution microscope.
Super resolution microscope? Can it leap tall buildings in a single bound? Does it have X-ray vision? Can it fly? Does it wear tights and a cape?
No, but you can think of it as a light microscope with superpowers. Super resolution microscopy actually describes a bunch of different specialized techniques that let you get high resolution images using photons as a source of illumination. Remember when I taught you that scientists use different kinds of microscopes because they have different resolutions? Well, super resolution microscopy is a type of light microscopy, but it's able to take images that have a resolution that is 2 to 10 times higher than other light microscopes. That means you can get images that are almost the same resolution as an electron microscope.
Oh man, how can they do that? I mean, isn't that breaking the rules? What's the name of that scientist? Abby. Abby is going to be so mad when he hears about this.
Well, super resolution microscopy still follows Abby's equation for resolution, but special techniques allow you to use photons to obtain high resolution images. One super resolution technique is called structured illumination microscopy, or SIM for short. To understand how SIM works, I first need to show you what a moire pattern is.
Moire pattern? You mean like the eel?
No, it definitely doesn't involve eels. I'm sure you've seen a moire pattern before on TV, but just didn't know that it was called that. Here, let's watch Moire the weather eel. See how the stripes on his jacket appear to move around in a strange way as he moves across the screen? That is a type of moire pattern. Moire patterns occur when you have a series of regularly spaced lines or dots that are superimposed on another set of lines or dots. When this happens on TV, there are two sets of lines, one on the clothing the person is wearing, and the other created by the pixels within the video camera's sensor. The lines on the clothing are spaced so closely that the video camera's sensor cannot distinguish them. So when the person on TV wears something with closely spaced lines, it appears to shimmer. This is a moire pattern.
Whoa, that's really trippy. But how does this apply to super resolution microscopy?
With SIM, the sample is illuminated by a laser, but before the laser hits the sample, it first passes through a structure called a diffraction grating. A diffraction grating is a metal plate with very, very thin and closely spaced parallel lines etched out of it. After the light passes through the grating, it illuminates the sample and excites fluorescent molecules within the specimen. The patterned light generated by the diffraction grating superimposes with the high-resolution features within the specimen, creating a moire pattern. To create a single super-resolution image with this technique, the microscope must take 9 different images, each with the diffraction grating slightly translated or rotated like this. The moire patterns in each of the 9 images contain hidden information. Special mathematical algorithms are used to translate the moire patterns into a high-resolution image.
Oh wow! So math is used to decode the secret information in the images. This sounds like spy stuff. I feel like I should be a 00 agent. My name is Belle. Annabelle.
SIM is just one of the many different super resolution techniques. There are other techniques that can get even higher resolution images than structured illumination microscopy. One of these techniques is called stochastic optical reconstruction microscopy, or STORM for short.
Now that's a mouthful. All this talk of moire patterns and super resolution microscopy is making me hungry. Want to get sushi? I called dibs on the eel roll.